We're in chapter 12, right? 12.1 today and tomorrow. We're shifting gears into sequences. We've got 12 with an exclamation point. You know what that means? That means 12, and you're really excited about it. 12. What does it mean? You know? Eros? All the way to 12, huh? Yeah. Dot, dot, dot. It means multiply those together all the way down to 1. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And get the answer, which is going to be really, really big. And there's a button on your calculator with the exclamation point. So somebody have that? 12 exclamation points. Yeah. I need the whole thing there, Thea. What you got?
479001600.
Well, one more time. 47900? 1600. So 479 million. You guys getting that? No?
I'm not. I haven't even got the answer right now.
Anybody getting 12 factorial? Is that the answer?
Yeah.
Yep. All right. That must be it. That's verification.
Where'd you find that exclamation?
Yeah, so it's probably under the math features and the probability would be my guess. Yeah. So if you go hit the math button and go all the way over to probability, and that will be it's down there. So go under on the TI graphic calculators anyway. Go under math, hit the math button, and then go all the way to the right. So on the TI graphing, you hit the math button, then you go over a couple times to the PRB, the probability, and then you go down there somewhere. Anyway, we good with that? You guys find that button? If you have any trouble, grab me after. I can help you locate. All right, there we go. So we have 3 factorial, 9 factorial over 6 factorial. Now what I would suggest, you could just do them all if you want and figure it out, but it's easier to actually simplify. Can anybody tell me the answer right now, off the top of their head?
3024.
Oh, is it really? I'm thinking 36, but maybe I'm missing something. Oh, no, you're right. I'm thinking wrong. I'm sure you're right. 3024. Yeah, I can't do it off my head. I was thinking I could because I was thinking it was different. I was wrong. Yeah, so, but still, it is still true that here's what I would do. I would look at 9 factorial, and I would think that's 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. And 6 factorial is 6, 5, 4, 3, 2, 1. So these all cancel. You know what I mean? I would just cancel off the 6 factorial part. So really all I need to do is 3 factorial, which actually that's just 3, 2, 1, huh? 3, 2, 1 times 9, 8, 7. I mean, it saves a little bit of work. It's not the most important thing in the world. Is that 3024? 3024. Okay. And it's 3024. So you can save a little bit of work that way. This is called factorial. When you put 3 with the exclamation, it's called 3 factorial because it has a bunch of numbers factored, meaning factors are things multiplied, right? It's a bunch of numbers multiplied. 3 factorial. All right, so however you want. So. All right, so here we go. So they're giving me a curly bracket thing here. Curly bracket, well, here, let me do it this way. So they're saying A, notice this here, I'm just going to write this over here bigger. A sub n is curly bracket n over n plus 8. What does that mean? Well, so we're entering a new area here, so we need to learn to speak their language. So this is the language of sequences. So how this works is basically A sub n. It's probably easiest if I just crank a few out. Let's find A sub 1. How do you find A sub 1? You're letting n be 1. So plug 1 in for n in that formula. It's 1 over 1 plus 8. It's 1/9. So it's just like plugging into a function, basically. The n is, it's like f of x. It's like f of n or something, right? The n is the subscript. But it's like plugging into a function. So a sub 1, I just plugged in a 1. Now let's find a sub 2. How do we do that? Plug in a 2. Now I'm going to plug in 2 for n in the formula. You just keep plugging. It's like plugging in for x in a function. So 2 over 2 plus 8. What is that? 2/10. Reduce that 1/5. So here's a sub 1. Here's a sub 2. Let's find a sub 3. Plug 3 into the function. 3 over 3 plus 8. What's that? 3/11. Plug 4 in. A sub 4. My a's are looking like 9s. But these are a's. A sub 3. A sub 4. 4 over 4 plus 8. What's that? 4/12. 1/3. And I think they want 5. Which one do I? Yeah, first 5 terms. So a sub 5. And that's going to be 5 over 5 plus 8. What's that? 5/13. And we're done. We found the first 5 terms in this sequence. Does that make sense what I'm doing there? I just plugged in 1, 2, 3, 4, 5. We could keep going. They asked me for the first 5. So that's, see how they say 4 parts remaining? They're going to, hey, what's A1? Then they'll ask you for A2, A3, A4, and A5. We just found them all. So it's just plugging into a formula is all it is. But that formula is really a sequence. In a minute, we're going to say this is a sequence of numbers. This is 1/9 followed by 1/5 followed by 3/11. It's a sequence. A1, then A2, then A3, etc. That's kind of where we're going eventually. A list. The sequence is a fancy name for a list. Basically, a list of numbers. All right. Let's do this one. All right, there we go. So same kind of thing. They want you to take that formula, plug in 1, plug in 2, plug in 3, plug in 4, and plug in 5. They want the first 5 terms. So go ahead and take that and plug them in. Give you a second there. So plug in 1. It's 3 to the 1 power over 4 to the 1 power plus 9. What's that? 3 over 4 plus 9. 3/13. So there's a sub 1. And then a sub 2 is 3 to the 2nd power over 4 to the 2nd power plus 9. What's that? 9 over 16 plus 9. 9/25 is a sub 2. And then a sub 3 is 3 to the 3rd power over 4 to the 3rd power plus 9. What's that? 27 over 64 plus 9, which is 27 over, what's that, 73? A sub 3, 2 more. A sub 4 and a sub 5. So a sub 4 would be 3 to the 4th power over 4 to the 4th power plus 9. They're getting big here. It was at 81 over 256 plus 9. So what's that? 81 over 266, 265. I think, right? 266, yeah, right? And then one more. A sub 5. You okay with what I'm doing there? Just use your calculators if you need to. A sub 5 is 3 to the 5th over 4 to the 5th plus 9, which is 243 over something big. 5, 12, yeah, 1024 plus 9. So that's 243 over 1034, 1033. Like that. There we go. A1 through A5. Making sense? We all good? So we're just plugging into the formula. Plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. All right. Whenever they say type an exact answer, they always mean we don't want decimals, because you got to round decimals. Well, usually, right? So, all right, same kind of thing. They're giving me a function here, and they're saying find A1. Find the first 5 terms. So A1 or F1 or whatever they're calling it here, I don't care. They're actually saying it's F1. No, over here it's A1. All right, whatever. Is just that. And I just stop right there, huh? 8 over e to the 1. Done. Because remember, e is a special number, right? Remember, e is 2.71828, blah, 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 blah. It's a special number, so I'm not, but it goes forever. Like pi, e goes forever with no pattern. You know what that's called? What's a number that goes forever with no pattern called? Anybody know?
What?
A decimal number that goes forever with no pattern. Like pi. Right? Pi goes forever with no pattern. 3.14, and off it goes. Nobody knows that? It's special. It's special. It's called an irrational. Anyway, you're not going to be tested on that. E and pi, those are irrational, meaning they're not a ratio. They cannot be made into a fraction. That's what it means. You can prove. We don't have time, but you can mathematically, logically demonstrate that things like the square root of 2. The square root of 2 is also irrational. Square root of 2. Do that in your calculator. Any square root that's not clean is irrational. Like, square root of 9 is just 3, but square root of 10 is irrational. Meaning the decimal goes forever with no pattern. And you can prove it. Anyway, we're not going to do that. So a sub 2. So anyway, e is irrational. So the decimal goes forever, so we can't write it down unless we rounded it, and then that wouldn't be exact. Yeah, I might be losing the point. Let me get back to the point. What is the point? They said exact answer. So I have to leave E. I can't put in a decimal because the decimal will go forever. I'd have to round. I wouldn't be exact anymore, right? So just leave it that way. A2 is that. A3, this is a simple question in the end then. Is that? That's 3 there. A4, you get the pattern, right? I mean, this is a nice one. I'll put a lot of these on the test. All right, there we go. That's all. All right. We're going to play the game. These are some of my favorite ones where you work it backwards. So they're going to give me a pattern, 1, 1/3, 1/9, 1/27, ... And they're going to say, hey, what formula is making this happen? What formula is making this happen? In other words, this is A1. This is A2. This is A3, right? 1 is A1. 1/3 is A2. 1/9 is A3. 1/27 is A4. You come up with a formula. Like A sub n equals n plus 1 over n cubed. Or, some kind of formula. That's not it at all. But some kind of n formula that will make, when you plug in a 1, will make it 1. When you plug in a 2, will make it a 1/3. When you plug in a 3, it'll make it a 9. When you plug in a 4, it'll make it a 27. Can you come up with some kind of formula that will do that? So we're working backwards. These are hard. These are tricky. Let me give you a second. What is it? Has somebody got one that they think it is?
1/3
A sub n is 1/3?
times, raise to the n minus
1 over 3 to the n minus 1, you mean? Or the
the whole thing.
The whole thing? That's actually the same thing. Either way. To the n minus 1 like that? Is that right? How do we know?
Yeah, because,
You test it.
You test it out. Yeah. We're thinking like a scientist now. This is exactly how this is science technically we're doing right now. Not math, meaning working backwards, right? This is what scientists do. They observe things happening in the skies or in the human body or in the ocean or whatever, and they go, what's the rule making that happen? What's the rule making that happen? Right? And they try to work backwards to the rule. That's called inductive logic. Normally, math formal is the opposite direction. It's deductive logic. This is inductive right now. Deductive is, I don't know, I don't want to use up too much time, but math is usually, even though this is kind of math too, but math is usually deductive logic, which means it's things like, it's surefire, it's always certain, it's never in doubt, because it's kind of simple, really, is why it's always so sure. For example, if I said, hey, I'm thinking of a number in my head, and it's bigger than 4, then, logically, your number must be bigger than 3 also. That's true. There's no way that could not be true. right? If you're thinking of a number bigger than 4, then you're also thinking of a number bigger than 3. For sure. Right? Now, you think, well, yeah, obvious. Well, right, you know how sure that is? That'll never be overturned, right? All of math is built on things that sure. That's called deductive logic. Like if the first thing's true, the second thing must be true without exception. That's how solid math is. That's called deductive logic. Whereas what we're doing right here is called inductive logic. It's how science works, and it can do some greater things, but it's not 100% reliable. Meaning, you look at a pattern in the skies or in the body or wherever, and you say, I think this is the rule making that happen. Now, it's never sure because you've not seen everything. You can never know for sure if the rule is really the rule unless you've seen everything. But you do the best you can. You try to come up with a rule that describes the known data. Does this rule describe this known data? Well, how do we figure that out? We plug it in, huh? Let's try it out. Let's see if Robert's right. So, whoops, I thought I changed my pen there. Okay, so let's go down and try that. 1/3 to the 1 minus 1. I'm trying a sub 1 here. What is that? 1/3 to the 0. What's anything to the 0 power?
1.
Ah, Robert, you're looking good. How about a sub 2? 1/3 to the 2 minus 1. 1/3 to the 1. 1/3. Is that a sub 2? Look at that. Robert, you're a ringer. We're going to have to hold you out of the next one. You're too good at this. Or you've already worked ahead, huh? 1/3 to the 2. 1/9. Beautiful. Robert's got it, huh? It's cranking out those numbers beautifully, isn't it? Do you see how it works? So that is the right formula. 1/3 to the n minus 1. Right? 1/3 to the n minus 1 is the right formula. It's cranking things out. You see how that power, how Robert figured that out, right? These are powers of 3. This is 3, 3 times 3, 3 times 3 times 3, 3 of them, right? So he's thinking there's a 3 in the bottom, but the power is in minus 1 because the first one's just 1, which produces a 0 power, which is the 1. That's how you would arrive at that conclusion. Now, I made a statement and said, wait a minute, this is inductive logic. It's not certain like deductive logic is. How's it not certain? I mean, that's certainly the formula, isn't it? 1/3 to the n minus 1.
It's just the equation for this.
So this is how science works, right? So I didn't get this until I was beyond, I was in higher classes. So I wish somebody had explained it to me earlier. So I'm trying to bring it to you. How science and math work, how they work is, so scientists look at things like I said, in the skies or the body or wherever. They look for the rule. They say, we know this data. What rule would fit that known data? This rule seems to work. But then over time, technology improves, right? And we can see further than we saw before. Or we can see smaller things in the cells that we couldn't see, right? Electron microscopes can see tinier things. And anyway, we get more data. Because technology improves, we get more data. We get more information. And then we go, okay, the next number, now if this is really the formula, we would predict that the next number would be what? 1/81, because that'd be another 3. That'd be 3 to the 4th, right? And suppose they see further down or further up and they find out that it's actually 80. Then they go, oh, shoot. That formula was working for a while, but there's some deeper mystery that explains the formula here and there. Maybe. Or maybe they find 81 and they go, yeah, we think we got it. And they grow in their confidence, right? That's exactly the story of science, right? Do you know much of it? Right? Newton, right? The apple falling out of the tree, hitting him on the head. The old, the silly cartoon, right? What did Newton discover, right? About how gravity pulls on things, right? That's the whole apple falling. He discovered the principle that gravity was... Before Newton discovered that, they used to think that the heavier an object was, the faster Earth would accelerate it down. The heavier the object is, the faster Earth would accelerate it down. That's not true. But that's what it looked like in the early days of science, right? Because they'd see a rock and a feather, and they would drop the rock and the feather, and the rock would go zip, and the feather would go, they go, oh, it's because the rock's heavier. Wrong. They thought the rock's heavier, so the Earth pulls faster on heavier things. Not true.
because then later on, it looked that way at first, later on, they developed a vacuum, technology improved. I mean, you know, suck the air out, not a vacuum on the floor, right? They got a vacuum tube with no air in there, and the gloves, and they put the rock and the feather with the no air in the tube, and they let them go, and the rock and the feather went boom, together. They went, uh-oh, we were wrong. Looks like Earth is pulling on everything the same, but the wind resistance can slow down lighter objects. New principle. And that's what Newton came out with, right? And then for a long time, Newtonian physics, as it's called, reigned, seemed to be the truth for everything we'd seen. And then Mr. Einstein came along, and we were able to measure things near the speed of light, right? And then it turned out Newtonian physics was only true for slow-moving objects. It really wasn't the whole story, and Einstein proved some really weird things happen near the speed of light, right? That all objects travel relative to the speed of light the same. Who would have guessed? So strange. Meaning, if you're sitting on a train, I'm getting too much physics. I like physics. I think physics is very interesting. If you're sitting on a train and you're going down the tracks and you throw a baseball, so if you're on a train moving 10 miles an hour, and you, right, standing on top of the train, moving 10 miles an hour, and you take a baseball and you throw it at another 10 miles an hour from your hand, relative to your hand, to somebody on the ground, not on the train, they'll catch it at 20, right? Because the train was moving the ball at 10, and then you moved it at another 10, it's moving 20, you just add those. Well, not really. It looked like that at those slow speeds. That was Newtonian physics. But then Einstein proved if you're moving on that train at the speed of light, and you turn on your headlights and they shoot away from the train at the speed of light, how fast will they hit the man on the ground? It should be 2 times the speed of light, right? Because the headlight is already, without the headlight being on, the train is moving at the speed of light. And then when the headlights turn on, they move away from the train, like the baseball, at the speed of light. So that should be coming at the man on the ground at 2 times the speed of light, but it comes at the man on the ground at exactly the speed of light. Einstein proved everything moves relative to the speed of light the same. Because that seems to be the fastest speed. Now there's new things that say maybe not. So anyway, I'm doing too much physics. But I think it's very interesting. So that's how science works. They just keep finding more, and the theories develop and change. So we're doing a little bit of inductive logic here. Can I, you guys got me in a story mood. I don't know if you got me. The problem did. So while you solve this problem, let's try this one again. We need a formula. So we need an a sub n, same thing. So we got 5, -10, 15, -20, So this is A1, this is A2, this is A3. Robert, you're not allowed to play this time. You're too good. Hold your formula to yourself. We'll let everybody else try. Let's try that out. So while you do this, I'm going to tell you a story that I heard, which I think is very funny. The FAA, no, not the FAA. That's it. Yeah. The Federal Aviation Administration, the FAA, the charge of planes for America, they have a chicken gun that shoots dead chickens at the windshields to test the strength of the windshields of the planes. They have this high-tech chicken gun. They've had it for a long time, I guess. Anyways, again, they load in dead chickens. They crank it up to like 200 miles an hour because, planes flying up there, and they're going to hit birds at high speeds, right? Anyway, so they shoot it at the windshields and make sure the windshield doesn't break, so the planes are solid. Anyway, there's this is a true story. There was this train company, and it made me think of with the trains. The train company in Europe somewhere, I can't remember, it was Germany or some country in Europe, was developing high-speed trains, and they heard about the America's FAA's chicken gun, and they said, can we borrow the chicken gun to shoot at our train windows to make sure our windows are solid? So the FAA let them use it, and so the train company in Europe, they loaded up the chicken gun at whatever miles per hour their trains go, 100 miles an hour, whatever, their bullet trains, and they shot the chicken at the window of the train, and the chicken burst right through the window of the train, burst through the steering column inside the train's engine, and lodged into the back wall of the chamber of the train. They were shocked by the results. They thought, what? We thought our windows were strong enough? That thing just demolished. What happened? So they wrote back to the FAA, and they said, what happened? Are you sure this chicken gun is calibrated right? Is this right? This can't be, And so the FAA said, send us all your data. Send us all your data from the experiment. So, and we'll try to give you an answer what happened. We'll check our machine. We'll try to let you know. So the European company sent all their information to FAA. FAA read over all the, they record everything in these experiments, read over all the data. They sent back an email finally after like a couple months of researching it, sent an email back to the European train company with the following line: next time, make sure the chicken is fully thawed. The chicken was partially frozen, and so that's why it burst through everything. Thaw the chicken when you use the chicken gun. They shot a rock-hard chicken through the train is what they did. The temperature of the chicken is important. All right, I thought that was a funny story. So all right, so let's look at this. So anybody got the formula? What is it? You guys weren't listening to my story, and you were solving the problem, right? How we doing? Are you a future scientist? Think backwards from what you see to a formula. What formula is making that happen? Maybe it helps you write things out. This is 5, clearly. This is 2 times 5. Other than the sign, this is 3 times 5. This is 4 times 5. Other than the plus minus thing, this one's plus, this is minus, this is plus, this is minus. So it's, 1 times 5, 2 times 5, 3 times 5, 4 times 5, isn't it? So a sub 1 is 1 times 5. A sub 2 is 2 times 5. A sub 3 is 3 times 5. A sub 4, other than the sign, we'll get the plus minus thing in a minute. A sub 4 is 4 times 5. So a sub n is what? N times 5, or 5 times n, either way is fine. Doesn't that make sense so far, other than the plus minus? Does that make sense? Because if you put in a 1, that'll be 1 times 5, which is 5. Put in a 2, that'll be 2 times 5, which is 10. That's right. Put in a 3, that'll be 3 times 5, which is 15. That's right. Other than the plus minus. So far, so good? Does that make sense? N times 5. Now, what about the plus minus thing? How do we get it to go plus, minus, like that? With an N formula. Anybody seen this before? It's a standard thing. They do it all the time. Robert, what do we got there? You know this one?
Negative value, maybe?
It's -1 to the n or n plus 1. I never know. I just have to tinker with it to figure out. You put -1 to the n or maybe n plus 1. I'll look and figure out which one. And that's the toggle switch. That's like a light switch, off, on, plus, minus. That's what makes that happen, is -1 to the n. But whenever signs are switching, it's either -1 to the n or it's -1 to the n plus 1. Test it out to figure out which one it is. So let's test it out. If I put in a 1 to both these, the first one will be negative. Whereas if I do this one, the first one will be positive. Which is the first one, positive or negative? Positive. This is the one. Everybody see that? If you make that n plus 1, -1 to the n plus 1, it'll work. There's our formula. Let's test it out. A sub 1 will be 1 times 5, and then -1 to the 1 plus 1. So that'll be 5 times -1 squared. It'll be positive 5, won't it? But then a sub 2 will be 2 times 5 -1 to the 2 plus 1. That's going to be -1 to the 3. It's going to be minus 10, isn't it? So it's working. See that? So it's -1 to the n or n plus 1, depending whether you want to start negative or start positive. And I don't memorize that kind of thing. I just test it at the moment. Comes up a lot. If you go on in math science, they use that toggle switch for signs often. You saw it here first. All right. Sequences. All right, so A1 is -2. AN is n plus AN minus 1. Okay. So this is recursive. I'll explain what that means in a minute. So first off, what do they want? They want the first 5 terms. So they want A1, A2, A3, A4, A5. Well, A1, they're just handing us that at a silver platter. There it is. A1 is -2. What about A sub 2? How do we find A sub 2? Well, let me take this formula here and put it in more common language for you. It's saying the nth term, or any term, let me just say any term. Any term, this means nth term, right? Any term is equal to n plus the previous term. That's what A sub n minus 1. Notice how that n minus 1 is a subscript, right? It's low down, right? Which means it's meaning the term one back, the previous term. N minus 1 is one back, huh? So what this formula is saying is you want any term? Take n, whatever number you're on, and add it to the previous term. That's what that's saying in common language. That's why it's called a recursive formula, because recursive means you got to go back to the previous number in the list. You got to recur. You got to go back. So it's saying if you want to find any term, take the number you're on and add that to the previous term. So if you want to find term number 2, take a 2 and add it to the previous. So that would be what? So a sub 2 will be 2 plus, what was the previous? Minus 2. So a sub 2 is 0. A sub 2 is 2 plus the previous term. Previous term is negative 2. Does that make sense there? Try a sub 3. See if you can find a sub 3. Same pattern. A sub 3 will be the number you're on, 3. Right? It's the n you're on. I'm on 3 now. Plus the previous term. So it's 3 plus, what was the previous term? 0. So it's 3. A sub 3 is 3. Does that make sense? Fine. See if you can do a sub 4. A sub 4 will be 4 plus, right, the number you're on, the previous term. 4 plus the previous term. It's recursive. It recurs. What was the previous term? 3, so it would be 7. And finally, can you do a sub 5? A sub 5 is 5 plus the previous, the number you're on plus previous. 5 plus 7, 12. Is that good? Does that make sense? You can read that then a little bit better? Questions? Feel free to slow me down. All right, so let's try that one. See if you can do the same kind of thing. They're giving you A1. It's 6. They're just handing you that on a silver platter. And then they're telling you how to find the other terms. So see if you can find a sub 2. Bless you. So find a, give you a second there, find a sub 2. This is a sub n minus 1, which means previous. Over n. That's what that's basically saying, huh? A sub n minus 1 means one term back. N minus 1, right? So previous term over n. So it's going to be, the previous term is going to be 6 over n. N means the number you're on, huh? Which is 2. I'm on 2 right now. So that's 3. Good. So a sub 1 is 6. A sub 2 is 3. Good so far. Try the next one. Try a sub 3. Give you a second there. Try to go all the way through to a sub 5. Doing okay? So a sub 3 is the previous term. So previous over 3. So it'd be 3 over 3. 1. Good to there. A sub 4 is previous. I got to spell it right. Previous over the number you're on. 4. That'd be 1/4. Good. And then a sub 5 again is previous over the number you're on 5. So that'd be, well, that was, sorry, 1/4 over 5. Wouldn't you to, good so far, wouldn't you to clean that up? Yeah, remember, this is really 5 over 1. You just flip it up to be 1/5. Have you seen that kind of thing? When you have a fraction underneath a fraction, you just flip it up, right? So it becomes 1/4 times 1/5, 1/20. Everybody good with that? Why? Because I want you to, I don't want you to think it's just magic or something. It's because it's 1/4 divided by 5, right? 1/4 over 5 means 1/4 divided by 5, and that's 5 over 1. Remember what you always do when dividing on the right of a fraction? You flip it. So that's all I'm doing. You'll do that a lot in calculus, so you want to be comfortable with that. Whenever you have a fraction, like 1/4 over another fraction, you just grab the one on the bottom and flip it upside down and multiply. inverted multiply, right? Good, questions on that? Recursive? All right, so A, oh yeah, this is going to be the same kind of thing, it's just all letters. A1 is A, so we got A1, there it is, it's A. Now what's A2? Well, they're telling me A sub n is AN minus 1 plus 3D, meaning AN is previous, right, previous plus 3D. I don't even know what D is, it's just some letter. So what would be A sub 2 then? Over here, A sub 2 would be previous, so that'd be capital A, the previous one, plus 3D. Just like that. So, okay, what's A sub 3 then? It's, here, let me just write it. It's previous plus 3D. So it's previous, this whole thing, A plus 3D plus another 3D, which is A plus 60. Am I going too quick? Is that making sense? Right? The formula says you want any term, you take the previous, n minus 1, and you add 3D in the back. You just keep adding 3D to the previous term. That's what it's saying, huh? Does that make sense? So then A sub 4, again, will be previous plus another 3D. So what's the previous? The whole A plus 60. Add another 3D. That's A plus 90. And finally, get the pattern? Can we just jump to it? What's A sub 5 going to be? Yeah, you just keep adding 3D more, right? You always take the previous term and add another 3D, huh? Good. Greek symbol. Have we seen this before? Yeah, sigma. Yeah, that's sigma. It's what? It's a Greek S, and it stands for sum. What it says, it says add up the formula k plus 5 as excuse me, as you plug in k equals 1, k equals 2, k equals 3, etc. all the way to the last one, k equals n. This is where you start, and this is where you end. That's what those formulas. I think we had them one other time, didn't we? Or am I thinking something else? Maybe not. Anyway, so you have big Greek. It's a big Greek capital S. It's the sigma. Big Greek. It's just a Greek S. So when you see it, just think, oh, that's a big Greek S, and that S means sum. That's what sum means. Add them up, right? Sum them up. Add them up. It's a big Greek S. It stands for sum up this formula. Oops, this formula. Add up the k plus 5 formula. As you plug in, starting with 1, ending it in. So I'm going to take the k. I'm going to take the k plus 5 formula. Plug in k is 1, k is 2, k is 3, all the way to k is n. So when I plug in k is 1 to this formula, I'm going to get 1 plus 5 or 6. When I plug in k is 2, I'm going to get 2 plus 5 or 7. When I plug in k is 3, I'm going to get 3 plus 5 or 8. Dot, dot, dot. When I plug in k is n, I'm going to get n plus 5. And then I'm supposed to add, dot, 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 all those up. Does that make sense? That's what that Greek symbol means. It means add up this formula, starting at 1, ending at n, keep plugging in to the k plus 5 formula, and add them all up. That's what the Greek S is, sum them all up. So that's what we get. So they want you to go, okay, the first one's 6, the second one's 7, right? They just want this one, and then they want the dot, 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 they want the last one. So that would be n, they just want the first, second, and the last, it looks like. N plus 5. We don't know what they all add up to be. They didn't ask for that. They just asked us to give the first one, the second one, and the last one. They just want to make sure we understand the meaning of the symbolism. Is that okay? All right, the sum from k equals 0 to n of 1 over 9 to the k. All right, see if you can come up with this time they want the first, second, third terms and the last one. So see if you can come up with the first, second, third, and the last. So you're plugging into that formula. You start, this time at k is 0 instead of 1, huh? They can start you anywhere they want. They can start you at 7 if they want to. So they're starting at 0 for k, and they're ending at n. So you start by plugging in k is 0, then k is 1, k is 2, dot, dot, dot. The last one will be n. So when you plug in 0, you get 1 over 9 to the 0. What's that? Anything to the 0 power? 1, so that's 1 over 1, 1. Okay, and then the next one, 1 over 9 to the 1, which is 1/9. 1 over 9 to the 2, which is 1/81st. And this is 1 over 9 to the n. There's the first, second, third, and last term. Good enough? Making sense? All right, so the sum from k equals 8 to n of minus 1 to the k natural log of k. So same kind of thing. Looks like they want the first, second, third, and last terms. Let me give you a second. So you can find the first, second, third, and last. So the first one starts at 8, huh? Right? Right, you start at this one, you end at that one. So start by plugging in 8 and go forward from there. Give you a second. How we doing? So negative 1 to the 8, natural log 8. Plug in 8 there. Now, what's negative 1 to the 8th power? Yeah, positive 1, huh? Positive 1 because it's, an even amount of negative signs, huh? Negative 1 an even amount of times can be positive, and just ln of 8. You're just going to leave it. See how they say exact answer? You don't want to get a decimal there. So just leave that ln 8. The next one be k is 9. It starts at 8, goes up by 1 every time. So that'd be negative 1 to the 9th, ln 9. What's negative 1 to the 9th? That's just going to be negative, right? See how that's that little toggle switch, right? Like the light switch that I was telling you about, right? The negative 1 to a power just changes the sign. Negative, positive, back and forth, right? K is 10, is negative 1 to the 10th, ln 10, so that's going to be positive. ln 10, The last one is k is n. Plug in n. Negative 1 to the n, ln n. That's the last one. So first, second, third, and last. Is that good on that? How are we doing? Questions? I guess that's as far. We almost finished, but we weren't scheduled to finish, so we're okay. We're going to finish that tomorrow. It'll be the first thing you do over Easter break, I'm sure, right? All right, let's do not tomorrow, but it'll be due. Well, I guess it's over Easter break. So next week's spring break. It's Wednesday, right? Oh, it's Tuesday. It's due Thursday. Thanks, I'm getting lost. It's Tuesday. It's due Thursday. 12/2 will be after the break. Have a good day. Thank you.